Welcome to the deep dive. Today we're taking a really rigorous plunge into the life and ecology of an animal that I think is often just dismissed for its eccentric looks. The common warthog or Phecowerus africanus. You know, you picture that tufted tail sticking straight up when it runs, or its weird habit of kneeling to eat.
Right.
But we found this incredible stack of sources that reveals a surprisingly complex creature. One that's not only a master of savanna survival, but also, and this is the wild part, plays a totally unintended but critical role in modern scientific research.
That really is the revelation here, isn't it? Our sources today, they go so far beyond the standard natural history book.
Yeah.
We've synthesized everything from, these intricate, almost forensic details on the warthog's highly specialized diet.
Right, down to the specific grasses.
Exactly.
Yeah.
Tracing which ones it seeks out across seasons in Ethiopia to its unique physical adaptations, like the calloused pads it develops in utero. And then we pivot to something I think is truly unexpected. Its crucial indirect function in disease control. It turns out that the architectural choices a warthog makes for shelter are, well, they're a perfect gift for entomologists studying deadly vectors.
So our mission for you, the learner, is to really understand what defines the warthog's ecological niche and just how specialized they are. This will be a pretty thorough journey. We're going to move swiftly but analytically from identifying its favorite Ethiopian grasses, like Cynodon lampesis.
Boy, that's the favorite.
Exactly. Understanding the physiological compatibility that drives that choice, all the way up to analyzing how its burrow contributes directly to the study of trypanosomiasis.
Or African sleeping sickness.
In places like the Zambezi Valley in Zimbabwe.
Heat signatures lining
Get
up
ready
with
for
the soil
some
moisture drop.
fantastic
It's exactly
aha
where the
moments,
wildebeest
because
cut
the
through last
connections
season.
between,
If
a
the models
grazing
are right,
pig
those grasses
and
should
global
bounce back
health are
before
just
the next rains.
truly surprising.
But if
They
they're
really
late
are.
again,
And the
we'll need to
foundational
shift the
material for
transects
this deep
east.
dive, it's grounded in some highly specific ecological studies. We relied heavily on detailed diet analyses from Western Ethiopia, specifically the Gassy-controlled hunting area, or GCHA, and the Haro-Abitigo-controlled hunting area, HADCHA. We complement that with insights from Tanzanian savannas, general natural history, and then we culminate in those highly specific findings from the entomological research that used artificial warthog burrows. It's a fascinating mix of forensic botany, physiology, and epidemiology all centered on this one animal.
Okay, let's start by unpacking the animal physically. We need to establish its identity. The common warthog is classified as a medium-sized species within the pig family. So to give you some context on its dimensions, we're talking about an animal with a head and body length of, typically 0.9 to 1.5 meters.
Yeah, that's the range. And they stand between about 63.5 and 85 centimeters at the shoulder.
And there's a pretty big size difference between males and females.
Oh, absolutely. We see clear sexual dimorphism here. The males, the boars, they're substantially heavier. They can weigh anywhere from 60 to 150 kilograms.
Wow, that's a huge range.
It is. It really depends on their habitat and resource availability. But the females, the sows, they're significantly lighter, typically in that 45 to 75 kilogram range. And this size difference, it becomes really important later when we get into male competition and defense.
Of course. But the defining physical characteristics, the thing that makes them instantly recognizable, has to be those dramatic tusks. They have two pairs of these, and they're constantly growing canine teeth. The sources detail that the upper pair is the most visually impressive.
They're stunning. They can get up to 25.5 centimeters long.
And they have that crazy curve, right? Like 90 degrees or more, just sweeping back.
Exactly. But it's actually the shorter lower pair that are functionally the most dangerous. Well, they're actively maintained. They become razor sharp precisely because they rub against the inside of that larger upper pair every single time the warthog opens and closes its mouth.
So it's like a self-sharpening system.
It is. That continuous friction keeps the lower set perfectly honed, creating these lethal cutting edges.
And this is where we hit that classic myth versus the scientific fact. The common myth, and you can see why people think it, is that they use these magnificent tusks for rooting or digging.
Right, for digging up bulbs and tubers.
But the sources are really emphatic on this point.
Yeah, they really are. The tusks are not tools for digging. Their function is purely strategic and combative.
For fighting.
Almost exclusively for fighting. The heavy upper tusks, they're like shields during those male sparring matches in the rutting season. But the razor-sharp lower set, that's for defense against major predators like lions and leopards. A cornered warthog is anything but an easy meal. It can inflict severe disabling wounds with those lower tusks.
Which immediately raises a question for me about their diet. If they rely so much on digging up tough rhizomes, and the tusks are only for combat, how on earth do they excavate the soil? What are they using instead?
It comes down to powerful muscular strength, mostly in the neck and shoulders, combined with their highly specialized snout, and critically, their feet.
Okay.
They use a combination of a scraping motion with their hooves and then that tough cartilaginous disc on the end of the snout. It's strong enough to penetrate and displace soil to get at those underground energy sources. It's a very specialized kind of rooting that requires constant kneeling.
And we have to remember the physiological challenge here. They are highly specialized to thrive in an environment, the open savanna, where most other pig species just can't make a living.
That's right. They are the only pig species adapted to grazing in this kind of habitat.
And that adaptation required two big shifts, one mechanical and one physiological.
On the physiological side, they had to solve the problem of getting enough energy from tough, fibrous grasses, which is very different from their forest-dwelling relatives. So they're classified as hindgut fermenters.
Okay, so for you, the learner, what does being a hindgut fermenter actually mean for a warthog? How does that compare to, say, a cow, which is what we all picture as a savanna grazer?
It's a really key distinction among artiodactyls. A cow is a ruminant, so it uses foregut fermentation. They essentially pre-process the food in the rumen, where microbes start breaking down cellulose before it's even fully digested. It's highly efficient.
Right.
The warthog, as a hindgut fermenter, has to process that tough material after it passes through the small intestine. It relies on microbial fermentation and a robust population of protozoans living much further down the digestive tract.
So lower efficiency, but the advantage is that the warthog can eat a lot of food quickly, and it doesn't have to stop and chew the cud like a ruminant
forages on the move.
Exactly. It's a trade-off.
Efficiency,
volume and speed versus absolute efficiency.
Every stride to
this
cover
specialization
ground
is fundamental to their ability to exploit
like
the
a plow
savanna,
through the dry
using
grass,
quick
and the
digestion
flick
to
of its ears
process
keeps
the
it
high
tuned
volume
to the
of grass
world.
they need.
And mechanically, this need to graze low-growing grasses leads us right to their most iconic behavior, that signature kneeling, which is known scientifically as carpography.
Right, and discussing carpography isn't just about a funny posture. It's about a deep mechanical adaptation for feeding efficiency. When they're grazing on those very short perennial grasses, they adopt that posture, moving on their wrists to get the closest possible crop.
It seems like an adaptation to just minimize energy expenditure while maximizing their time foraging.
It is. If they had to constantly bend their necks down or walk long distances for taller grass, they'd spend more energy than they gain. By kneeling, they stabilize their body right there, close to the ground.
And the most fascinating part of the specialization is that it's physically baked into their anatomy. It's not just something they learn to do as adults.
Precisely. To cope with the constant abrasion and pressure of moving on their wrists, they develop these tough, thick callus pads on those wrist joints. And what really elevates this from just a behavior to a fundamental specialization is the timeline.
When they develop.
Yeah, these protective pads begin to form very early during fetal development. The warthog is, quite literally, born ready to kneel. This feature protects them and enables them to be these incredibly efficient, low-level savanna exploiters. So while the warthog is technically an omnivore, it's capable of eating grasses, roots, fungi, insects, even eggs, and carrying ecologically. It's really functioning as a specialized grazer.
Right.
It focuses on the high-quality herbaceous plants and forbs you find on the savanna. And this dietary flexibility is what allows it to have such a wide geographical distribution.
And that flexibility is completely dependent on the calendar. Their diet is just dictated by the seasons of the African savanna.
In the heart of
Absolutely.
the dry season,
the whole
even
life
the
cycle for a
hardiest of
warthog
foragers struggle.
is defined by this
The land
critical
offers
seasonal
little more
shift
than
in
dust
foraging.
and memory.
During the
Yet
harsh
warthog
dry
keeps
season,
searching,
when the
snout
surface
to the
grasses get all
cracked earth,
dry and
hoping
tough
for
and
a scrap
nutrient
of
poor,
green.
their diet becomes severely restricted.
So they have to switch.
They have to transition almost entirely to consuming underground storage organs, bulbs, rhizomes, and nutritious roots.
And that powerful snout and rooting ability we talked about is crucial here. Gives them a double benefit, doesn't it?
It does. The excavation process doesn't just provide vital nutrients locked underground. Crucially, these underground sources often retain moisture.
So it's a water source.
It's a critical source of water during extreme drought that would defeat other
In the
surface
heart of the
grazing
dry
animals.
season,
They're
every
literally
drop
digging for their
matters.
dinner and their
After
drink at the
hours
same
of
time.
rooting
We
through
also
the baked
saw
earth,
in the sources
this warthog
slightly
has carved out a
opportunistic
pocket of
behavior
life.
during that dry
Cool
season.
water seeps
They
up
seem
from
to
below
show
the
a clear
cracked clay,
preference for
enough to quench
exploiting
a
human
desperate
activity
thirst.
zones.
That's
For a
the
moment,
shrewd side of the
relief
warthog.
replaces
The research highlights that during the dry season, they often prefer to forage near domestic cattle enclosures, or bomas. And why is that?
They're there to exploit the nutrient enrichment from the livestock excreta. That localized input of nitrogen and other minerals allows higher quality grasses and forbs to thrive in a small area. It offers a much more nutritious resource than the dry, open savanna.
This brings us right to the incredible detail from that ecological research in western Ethiopia across the Gassi and Haro Abitiko controlled hunting areas.
There it is.
Right, from 2017 to 2018.
This study went totally forensic to figure out exactly what these animals were eating.
The methodology was the key to its precision. They used feeding quadrant surveys to confirm grazing sites, looking for clear scars on plants and fresh fecal deposits. And then they performed microhistological analysis of the feces.
Okay, so what does that involve?
It involves preparing and examining fragments of the plant's leaf cuticle, which are resistant to digestion. It allows researchers to identify the exact species consumed.
They tell us how
it's incredibly labor-intensive, but it's the only way to reconstruct an animal's menu with that much precision.
And the sheer variety of what they eat is remarkable, even if they're focused on a few staples. It is. The researchers identified, 41 plant species in the GCHA feces and 45 in the EDCHA feces, and these were classified into 4 groups. Graminoids, which are grasses, and the largest group, forbs, shrubs, and climbers.
A wide menu, but as you said, the survival really hinges on a specific core set of plants.
Exactly.
So let's focus on those staples. These sources define them as foods eaten in large quantities, 3% or more of the diet, and preferred foods as those eaten more than they're actually available locally. What were the heavy hitters?
Okay, so starting with the GCHA area during the wet season, 3 species had these incredibly high relative frequency occurrences, or RFOs. The absolute top was Cynodon lymphoensis at 75.5%.
Wow, so 3 out of every 4 plant fragments they analyzed was this one species?
Pretty much. And right behind it was Cynodon dactylon at 69%, and then a sedge, Cypress hisuanus, at 47%. These 3 were the absolute core of the wet season diet.
That's an immense reliance on 2 specific types of Cynodon grass. What makes Cynodon lymphoensis so physiologically compatible for them?
Well, the preference is most likely driven by a high ratio of digestible nutrients compared to tough, indigestible fiber. And that is absolutely critical for a high-gut fermenter. Cynodon species are well-known high-quality grasses.
So they're getting the most bang for their buck.
Exactly. For the warthog, maximizing the energy return on their rapid grazing is paramount. Selecting these soft, nutritious grasses in the wet season minimizes the mechanical work their digestive system has to do.
And how did that core menu shift when the dry season hit in the other area, the H8DC8 area, where resources would have been scarcer?
This is what's so striking, the stability. It really reaffirms how indispensable these plants are. The top 3 persisted. C. lymphoensis was still dominant at 76.5%. C. dactylon was just behind at 73.5%, and H. rufa actually stepped up significantly to 57.5%.
So the percentages are still high because they're being forced to seek out these specific clumps, even as other forage disappears.
That's right. And we do see a few other species like Hyperrhenia hirta emerge as staples, likely because they're just more available relative to other grasses in the drought.
The study also used an acceptability index, right? A score above 0.5 showing a consistent preference. This really nails down their dietary loyalty.
It does. We see high acceptability across both seasons, which cements the status of their perennial favorites. In GCHA, Cynodon dactylon and C. lymphoensis were year-round favorites, and the HABCHA area showed similar consistency.
So the warthog is basically acting as this ecological filter, showing extreme loyalty to a handful of nutrient-rich grasses year-round. It's a specialist disguised as an omnivore.
That synthesis captures the strategy perfectly. And while we know C. dactylon is a globally recognized staple for warthogs that's been documented across Tanzania, Kenya, South Africa, this Ethiopian study provided a really novel finding. The extremely high proportion of Hyperrhenia rufa, and specifically the heavy reliance on Cynodon lymphoensis as year-round staples, that had not been widely reported across the warthog's entire range before.
So it highlights a local adaptation.
Exactly. It highlights that while the warthog's physiological constraints drive them toward high-quality grasses, the specific species they rely on are highly locally adapted. They're maximizing the utility of the best forage available in their immediate ecosystem.
All right, let's shift from diet to social architecture. They are clearly adapted to open country, and unlike some other large savanna mammals, the sources say they're not territorial. So how is their social unit,
In the late gold
the
of
sounder,
afternoon,
organized?
a warthog
Well, while they're
sow
not
leads her
strictly
family
territorial,
across the
they
open
do
plain.
maintain and occupy
Her
a
latest
distinct
litter,
home
still
range.
striped and
And the
bright-eyed,
sounder itself is
presses close to her
fundamentally a
heels,
female-based
while last
social
season's
unit.
daughters
Okay.
bring up the
The
rear.
core is typically
Together
a
they
single
move as
adult
one,
female,
bound by the
her
quiet
current litter
strength.
of piglets, and often some female offspring that she's retained from previous litters. The foundation of warthog society is built on these strong, enduring natal bonds between related females.
So the girls stick together, maintaining the sounder. What about the boys? Where do the males fit into this?
The males disperse early. They leave their natal groups, usually within the first year of life, which is pretty standard for many species where the male's role is primarily reproductive. Subadult males will often form these temporary loose bachelor groups, traveling and feeding together. But once they reach full adulthood, they become largely solitary. An adult male only joins a sounder when he detects an estrus female, and that's what drives the intense competition.
Speaking of which, the warthog is a seasonal breeder,
The boar approaches with
timing
caution,
reproduction
every
to
step
maximize
measured,
resources
nose
for the
testing
young.
the air.
Let's get into
Scent
the
tells
mating
him
process.
more than sight.
the
The sow
rut.
carries a
The
message
rutting
in the
period
molecules
usually
she leaves
happens during the
behind.
late rainy
A soft
season or
grunt,
the early
a flame
dry
and curl
season.
of the lip. His
And the
courtship
timing is
begins.
critical because
She
the
neither
gestation
refuses nor-
period is about 5 to 6 months.
Which means the bolting is timed for the start of the next rainy season.
Exactly. It ensures fresh, high-quality grass is immediately available for the piglets. And the mating system itself is characterized by what they call overlap promiscuity.
That sounds inherently competitive. What are the specific tactics the boars use?
They employ two main distinct strategies. The first is the highly aggressive staying tactic, where a dominant boar will actively stay with and defend specific females, engaging in these fierce sparring matches.
Using those upper tusks as shields.
Right. And the second is the roaming tactic, where boars are just constantly moving across the landscape, seeking out sows and competing for momentary access, sometimes lying in wait for them to emerge from their burrows at dawn. Physical dominance is everything.
Once a sow is successful, she temporarily isolates herself to give birth. Litter sizes, as noted, can be up to 8, though 2 to 4 is typical. But then we get to this surprising cooperative breeding behavior, allosucking.
This is a truly fascinating observation. Allosucking is the term for a female nursing foster piglets, and warthog sows have been observed doing this, especially if they've lost their own litter or are nursing their own alongside adopted young.
And evidence points toward kin altruism, right? Because the sounder is so female-centric.
That's the leading hypothesis. It's likely a complex interplay. While it's tempting to call it pure altruism, it's probably kin selection. The females in the sounder are usually related, so helping a niece or cousin's offspring survive still promotes the shared gene pool. Plus, the sow is already lactating, so the physiological imperative to empty the udder remains. But regardless of the driver, it shows a remarkable level of cooperative tolerance.
Now let's revisit the warthog's vulnerability. We established they have sparse hair and lack subcutaneous fat. This makes them highly susceptible to temperature extremes, turning shelter from a convenience into an absolute necessity, especially for the young.
It is their primary behavioral driver. They cannot effectively thermoregulate. They use behavioral tactics like wallowing in mud for hot temperatures, which helps dissipate heat.
But when temperatures drop,
When they drop, piglets in particular must huddle tightly together in the insulated environment of a burrow to maintain a warm body temperature and survive.
and this absolute need for shelter results in their defining ecological habit. They are the only ungulates in Africa that sleep underground.
And they achieve this by being superb resource managers. The warthog generally does not expend the monumental effort to dig a permanent sleeping burrow from scratch. Instead, they're famous for occupying and expertly repurposing burrows abandoned by key ecosystem
Beneath the quiet
engineers.
savannah,
Most notably,
an
the
entire
aardvark.
world lies
The
hidden.
aardvark.
So let's
This is the
elaborate
home
on the
of an
aardvark's
aardvark,
role. Why are their
carved
burrows so
patiently through
valuable to
packed
the
earth and
warthog?
clay.
Well, the aardvark
From this
creates
central
subterranean
chamber,
architecture
a web
of
of
exceptional
tunnels spirals
quality.
outward.
These
Sleeping
abandoned dens are
escape routes,
complex.
and
They provide essential security and thermal stability. They can extend incredibly deep, up to 14 meters long, and have multiple chambers, multiple entrances. These structures provide natural insulation against both heat and cold, which is exactly what the warthog needs. And since aardvarks often move on, their old dens become available for recycling.
And once inside these homes, they employ a specific defensive posture when settling down.
That's right. This is another key survival tactic. When entering a den for the night, they almost always reverse in.
So they're facing the entrance.
Their head and those formidable sharp lower tusks are facing the entrance. This allows them to either burst out rapidly or defend the opening if a predator, say a hyena, tries to get in. It's a very smart defensive layout.
And their primary defense above ground is just fleeing, right?
Oh yeah, their best defense is sheer speed. They can run up to 48 kilometers per hour. But they also engage in some surprising mutualism, allowing animals like banded mongooses and vervet monkeys to groom them for ticks.
Okay, we've established the warthog's deep behavioral reliance on these aardvark-initiated burrows. And now here is the incredible pivot to vector ecology and global health. The warthog's necessity, this search for a cool, dark refuge, creates an ecological hotspot that is accidentally vital for entomologists.
This is truly a perfect, if unintended, confluence of behaviors. The subterranean burrows become absolutely essential microhabitats for tsetse flies, Glossina spp, the vectors for trypanosomiasis.
Sleeping sickness.
Right. And because observing the tsetse fly's crucial reproductive cycle larva position in its natural state is notoriously difficult, scientists realized the warthog burrow provided a unique, natural, and protected laboratory.
The definitive research on this was done during the peak of the hot, dry season in Zimbabwe's Zambezi Valley in 1998, right? Between September and November, when temperatures are brutal. Why does a flying insect need the burrow so desperately then?
It's purely a thermal survival mechanism. The tsetse fly uses these burrows as critical refuges to escape the intense, high ambient temperatures which become lethal above a certain threshold.
And what's that threshold?
The studies show that the number of flies captured increased dramatically when the external air temperature exceeded 32 degrees Celsius. And to give you a scale of the heat, the maximum ambient temperature they recorded was a blistering 42.5 degrees Celsius. The surface just becomes a death zone.
So the burrow isn't just a hiding place. It offers crucial, life-saving thermal stability that the tsetse fly cannot find anywhere else on the surface during the day.
Degrees.
Exactly.
Just
the
a meter
microclimate
away,
is
tucked
the
into
key.
the earth. The
Researchers measured this precisely. The burrows are significantly cooler than the ambient air during the peak daylight hours, up to 3 degrees cooler than even the best artificial surface refuges.
And at night?
And conversely, they retain heat slightly better during the late night and early morning. This dual function of thermal stability makes them the ideal site for two critical activities: escaping heat and, most importantly, providing a stable environment for larva position.
To study this sensitive behavior, researchers couldn't just sit and watch a real burrow. They came up with an ingenious system involving artificial warthog burrows.
This was the methodological breakthrough. They constructed these by cutting and welding 200-liter steel drums, which were then buried in the ground so the entrance was flush with the soil, perfectly mimicking a natural den.
And they were fitted with traps.
Crucially, yes. They were fitted with specialized trapping systems. A wire frame covered with black netting inserted right into the mouth of the burrow. This allowed them to capture adult flies, especially pregnant females, at the exact moment they were seeking to enter and deposit their larvae.
It's important to clarify the tsetse reproductive cycle. They're viviparous, so they don't lay eggs. They produce a single, large, fully developed offspring sequentially as a puparium.
Right, which is immediately buried. This means the female's physiological status is everything. So researchers used ovarian dissection to classify the captured females. The most critical group was perinatal flies, females that were either full-term pregnant or just given birth.
And all the others were just using it for shade.
Pretty much.
Yeah.
The pre-full-term females were generally understood to be using the burrow solely as a heat refuge, not a maternity ward. This level of classification allows scientists to isolate the factors that specifically drive reproductive behavior.
Okay, so analyzing the mountain of data from these artificial burrows revealed these fascinating and crucial behavioral differences between the two main species they studied. Glossina morsitans,
Here, the researcher must collect
morsitans,
each one
and
by
Glossina
hand and record the
pallidipes.
sample. On the right,
And the research
a mesh
compared the
trap at
success in
entrance guides
untrapped
emerging
burrows,
pupa
where
into
they
a
just
collection
collect
bag.
pupae, versus the
design-
adult female
Just
collection
under the
rate
surface?
in the trapped burrows.
There they are.
Right, so let's start with the hard outcome.
Glossina morsitans pupae.
Actual larva
Tight
position
cluster,
success.
healthy pigment.
In the
We'll mark
untrapped
this burrow,
burrows,
but the
GM
next one gets a
morsitans
trap?
dominated the nursery.
That should
It accounted
intercept
for
any emergers.
59% of
Let's see what
all
the
the
night brings.
puparia collected.
So it seems
Caught
like
at
the
the
more
mouth of the artificial
successful
burrow,
species
the
in
full-term
choosing a
G.
site.
palpalis
That's what it
lies
looks
against
like
the
at
mesh.
first.
Her
But the
abdomen
picture
is
changed
swollen with a
dramatically
nearly
when they
mature
trapped the
larva,
adults
each
attempting
segment
to enter the
glistening in the
burrow.
sun.
How so?
The
When the
netting
traps
holds
were in
firm as
place,
she tests
they found that
every angle,
significantly
wings
more
thrumming, legs
full-term
scraping for
pregnant G.
purchase.
pallidipes were captured entering the
At first
burrows
glance,
than
the
GM
trap seems to
morsitans.
teem with
Really?
life.
Yeah, G.
Hundreds of
pallidipes made up
Glossina palpalis crowd the
67% of all
cone,
the
their wings
prenatal
shimmering
females
like
caught at the
bronze in the
entrance.
sunlight.
You'd
In the
expect
peak
a
months, the
thriving
capture rate of
breeding ground
perinatal
nearby.
G. pallidipes
Yet
was
sift
nearly
through the
double
soil
that
just
of
meters
GM
away, and only a
morcitans.
handful
Okay,
of pupae
this is
appear.
a massive
Freeze-
contradiction, and here's where the analysis gets really insightful for you, the learner. More G. pallidipes are entering, yet fewer of their pupae are found later. What does that gap tell us?
It leads to the critical finding that G. pallidipes are the more discriminating species,
They're pickier.
much pickier. The data strongly suggests that while a high number of full-term G. pallidipes will enter a potential site, a much greater proportion of them will leave without depositing a larva. They go in, they assess the microclimate, they inspect the substrate, and if it's not absolutely perfect, they leave to find a better spot.
So GM morcitans is more committed once they find a suitable location, which results in a higher success rate for deposition, even if fewer of them initially check it out.
Exactly.
This high level of discrimination by G. pallidipes suggests they have extremely specific requirements. What were the exact conditions they were looking for inside that burrow?
The requirements were highly precise. It's not a random act at all. Location preference within the burrow was extreme. The vast majority of pupa, over 73% for GM morcitans, and an even higher 83% for G. pallidipes, were deposited at the very rear, the deepest part of the burrow.
So the deeper or longer the warthog burrow, the more attractive it is as a nursery.
That's the
Inside
implication.
the dim belly
It's
of the
likely
artificial
due
burrow,
to increased
two
thermal
options await
stability
the
and
tsetse
humidity
flies.
the deeper you
On
go.
the left,
And the
bare,
substrate mattered just
sun-warmed
as much as
sand,
the depth,
smooth,
didn't it? They needed a
featureless, and
specific
open.
bedding
On the
material.
right, the
Absolutely.
same sand
Larvae
hidden
position
beneath the
demanded a
shelter of
precise
dry, crumbling
combination.
leaves.
Researchers provided trays of plain sand and trays of sand covered with leaf litter inside the burrows. The result was unequivocal.
What was it?
An astounding 97% of all puparia were found in the trays, containing sand covered with leaf litter.
So why the leaf litter? What essential function does that provide?
It provides several essential functions. First, it's camouflage, protection from predators like ants. Second, and probably most importantly, leaf litter helps stabilize the microhumidity and moisture content around the puparium, preventing it from drying out during the long pupal stage. It provides the exact environmental buffer the developing fly needs to emerge safely weeks later.
So we have thermal needs, substrate needs. Did the researchers see any indication that the tsetse were
From
factoring in
September to
external
November,
environmental
pupae counts
cycles
in the
beyond
colony
just the
fell by
immediate
more than
temperature?
2/3.
Yes, there was a
On the
clear,
right, we can see
proactive,
why.
seasonal
Rising
timing
groundwater
element.
infiltrates
The
the
total
nest,
pupal
flooding chambers
deposition
that
rates
once held
declined
hundreds of
steadily
developing
from
insects.
late
As
September
the
through
burrow fills,
mid-November.
the
And then
pupae are
stopped.
submerged and
After
suffocate.
mid-November,
Their cases-
almost no puparia
At the
are
mouth of a
found.
burrow, a tsetse
Researchers
fly hovers,
hypothesized this decline
tempted by the
occurred
shelter
because the
inside.
tsetse flies may be
Yet
anticipating
nature
the coming
carries
wet
its
season
warnings.
and the risk of
As
flooding.
the first rains
They
seep
seem to
into the
choose
earth,
not to
the opening begins
larvaposit
to
in
flood.
burrows that might soon be
Instinct tells the
inundated.
insect to
It's
turn
an
away.
avoidance of a predicted
There it
catastrophe
is.
for their offspring.
Beautiful.
So what's the
Perinatal
ultimate
female,
critical
still carrying her
significance of
larva.
this
We got
entire
her.
artificial
The
burrow
trap worked
methodology
exactly
for
as
human
we
and
hoped.
animal health
This could
efforts
change how we
against
sample
trypanosomiasis?
populations that breed
The
underground.
ability to use these
She's
artificial
secure.
burrows provides
Perfect
an
specimen.
invaluable novel method for sampling
left,
female
a
tsetse
perinatal
exactly at the
tsetse
moment
fly
of
mother,
larva position.
10 millimeters in
It gives
length,
unprecedented
carrying
access to
nearly
the reproductive
42% of her
phase.
body
Which was
mass as
impossible
fat.
before.
These
Practically
reserves
impossible
sustain
in
the
the field.
developing larva inside
Now,
her
researchers
abdomen.
can accurately
On the
capture
right,
these
the
perinatal
offspring
females
emerges from its
and compare the
puparium with
physiological status of the
density
mother,
spike near the
her
Zambezi just
size,
jumped again.
nutritional
I see
state,
it.
age, fat content,
temperature
with
holds,
the
we could
quality
be
and
looking at a
size of the
migration
offspring
push
she
within a week.
produces.
Let's flag
This
that zone for
simultaneous
field sampling and
mother-offspring
push the alert
measurement
to the
is
county
absolutely
offices.
critical
Done.
data for
Running the
understanding the
60-day
population
projection now.
dynamics of the disease vector.
So it allows for better predictive models.
Far more accurate models for disease risk. And it dramatically improves the strategies used for trypanosomiasis control, often focusing on disrupting this very reproductive cycle in these very burrows. The humble warthog
On
burrow,
bent knees,
this
the warthog
accidental
combs the
sanctuary,
turf.
has provided a
Tusks
key
sweep aside
breakthrough
the
in
dry
global
thatch,
health vector
and its snout
ecology
finds the
research.
sweetest
That
shoots
was
of Bermuda
truly a deep
grass hidden
dive.
close to
We
the soil.
tracked the warthog's
This posture keeps
specialization
its
all
sensitive
across
mouth
the African
protected
savanna.
and its mouth close to
We
the
followed it
prize.
from its highly
Each careful
specialized
bite is
knees
clipped.
on the ground grazing habit, detailing its preference for those highly compatible grasses like Cynodon lempuensis, a choice driven entirely by its hind-gut digestive physiology. And then we traced its essential reliance on that subterranean architecture, often initiated by the ecosystem engineer, the aardvark.
And we learned that the warthog's core behavioral necessity, seeking a cool, dark refuge to survive savanna temperature extremes, creates a predictable ecological hotspot. This refuge effectively becomes
On the
a
left,
vector
Glossina
laboratory
morsitans,
that scientists
savanna
can leverage.
specialist,
Right.
compact and
It allows
bronze,
them to
its
gain
wings
crucial,
folded like
otherwise
polished
impossible
blades.
get data
On the right,
on
Glossina
tsetse
palpalis,
fly reproduction,
riverine dweller,
revealing
darker,
these
damper,
subtle but
probing
vital
with a slender
behavioral differences
proboscis
between
and
species
loosening its tented
and providing
wings.
the data needed
Even
to
their
refine
grooming
disease
whip
control strategies.
Beneath the
The
scorched
combination of
savanna,
savanna
a
survival
pocket
and
of
global
still,
health research
cool
meeting
air
in the
settles
Warthog
in an
burrow
earthen
is just
burrow.
an incredibly
Here,
powerful
a
and surprising
warthog retreats
nexus.
from the sun.
Absolutely.
Its
So to
breath
wrap up,
slow
we
and
noted that
even
both
in the shade.
warthogs,
The
the primary
walls hold
host
a
animal for the
constant, gentle
disease,
chill.
and tsetse
Respite
flies, the
not-
vector, rely heavily on the thermal stability of burrows during periods of extreme heat, especially above 32 degrees Celsius. So here's a final provocative thought for you to consider, building on the implications of this shared confined space. If climate change projections hold true, leading to longer, more intense, and hotter dry seasons, thereby increasing the time that both the warthog and the tsetse fly vector are forced underground together for refuge, what unintended consequences might this shared, confined, and mandatory proximity have for accelerating
In this
disease
expanse
transmission
of
rates
golden grass,
and increasing the
every creature has
virulence
its
of
place.
trypanosomiasis in the
Warthogs
future?
root through the soil,
fascinating and
stirring up
sobering
insects.
question about the
Tsetse
future of
flies
this
test the
surprising
patience of
ecosystem
skin and
dynamic.
hide, yet pollinate
Until then,
and feed the web
keep
in turn.
exploring and
At the
observing
water,
those connections.
impala, zebra, and crane